Hello friends, our topic of discussion is JVM architecture, which is most commonly asked in Java interview question for beginners as well as for experienced. Let's understand in detail. First, we are going to understand virtual machine. It is a virtual representation of physical computer. We can call VM as guest machine and physical computer is called as host machine on which VM runs. A single physical machine can run multiple VMs and these VMs are isolated from each other. So we can see like we are having one laptop and we can have multiple OS installed on our laptop. Some people are using like Linux as well as Windows both. So what is Java virtual machine? But before that, let's understand two concepts like compiled language and interpreted language. So a compiled language is first compiled into platform specific machine code like C, C++. Interpreted language executes the instruction without compiling, like Python, JavaScript. So, Java uses a combination of both technique. Java code is first compiled into bytecode to generate class file, and this generated class file will then interpreted by Java Virtual Machine (JVM). Similar to virtual machine, JVM creates an isolated space on host machine. This space can be used to execute programs irrespective of platform or OS of the machine. So JVM consists of three different components like class loader, runtime data area, execution engine. We will understand in details further. So what is class loader? What is the function of class loader? So we are having .java file which is compiled and converted into .class file which is a bytecode. Now what is the purpose of class loader? So it loads the class into main memory. So we are having three steps: loading, linking and initialization. So in loading we are having three class loaders available in Java. First is Bootstrap class loader, second is extension class loader, and third is application class loader. Bootstrap class loader is root class loader. It is superclass of extension class loader and loads standard packages like java.lang, java.util, java.net, java.io from JRE lib directory. Now next is extension class loader. It is subclass of Bootstrap class loader and superclass of application class loader. It loads the extension of standard Java libraries, which is present under JRE lib ext directory. Let's say like we want to connect with MySQL database, and for that we require MySQL connector. So to connect with database we require package to connect with MySQL database. So there would be like MySQL connector and we can connect with that. So these things can be found under the extension directory. Next is application class loader. It is a subclass of extension class loader. It loads the file present at class path, and this class path can be modified by adding hyphen class path or hyphen cp from command line option. JVM use class loader dot load class method for loading the class into memory. So how it finds the classes? So first parent class loader will try to find the class. If in parent class loader is not able to find that, then it delegates the work to child class loader. And if the last child class loader is not able to load the class, then it either throws no class def found error or class not found exception. Next process is linking. After class is being loaded, it undergoes linking process. Linking a class or interface involves resolving dependencies and combining different elements. So there are certain steps involved while linking. First is verification. In verification, it checks the structural correctness of .class file. If verification fails, then we will get verify exception. Next is preparation. Then in this step, JVM allocates memory for static fields of a class or interface that and initialize with default value. Let's say we are having a static boolean value and we have assigned it with true. But in preparation phase, it will be initialized with false because the default value of boolean is false. Next is resolution. Symbolic references will be replaced with direct references present in runtime constant pool during resolution. Next step is initialization. Initialization involves the executing initialization method of class or interface, like calling the class construction, executing the static block, assigning values to all the static variables. So earlier we have assigned boolean static value to false during preparation phase. But now during the initialization phase, we are going to assign with true value. Next is runtime data area. So we are having method area, all the class level data such as runtime constant pool field and method data and the code for method and constructors are stored here. If method area is not sufficient for the program to run, then it will throw out of memory error. There is only one method area per JVM. For example, we can see a class student which is having fields name and role, and we are having constructor. So these details are loaded into method area. Next is heap area. All the objects and their corresponding instance variables are stored in heap area. There is only one heap area per JVM. So here we can see we have created an instance of student which is loaded into heap area. As method and heap area share same memory for multiple threads, that's why data stored in method and heap area can't be considered thread safe. Stack area. Whenever a new thread is created in JVM, a separate runtime stack is also created at the same time. All the variables, method calls, and partial results are stored in stack area. When stack size is not sufficient, then in that case JVM will throw stack overflow error. For every method call, one entry is made in stack memory, which is called stack frame. When all the instruction has been executed from that method and it returns, then entry for stack frame got destroyed. Stack frame is not shared. So the here stack memory is not shared, so we can consider it as a thread safe. Next is PC registers. So we are having n number of instructions to execute, and for that we need to identify the currently executing instruction, and PC register holds the address of currently executing instruction. Once the instruction has been executed, then PC register will get updated with the address of next instruction. It will point to the next instruction. Next is native method stack. So it is used to handle native method calls, which is implemented in language like C, C++, which stores information about calls, local variables, and runtime address. So we are having few advantages of using compiled language like C, C++, and we can leverage this by the use of Java native interface. So by which we can interact with the native libraries. Next is execution engine. So we till now class file has been created. Now our memory is ready. Linking process, verification process has been completed. Next comes with the execution of the program. So execution engine is responsible for executing bytecode, and with the help of these three components, programs are executed. So first one is interpreter. So interpreter reads and executes the bytecode instruction line by line, which makes it slower. When a method is called multiple times, every time a new interpretation is required. To overcome this problem, JIT compiler or JIT compiler or just-in-time compiler come into the picture. Execution engine first use interpreter to execute the bytecode. When it finds some repeated code, then it use JIT compiler, and JIT compiler compiles the bytecode and change to native machine code. This native machine code is used directly for repeated calls, which improves the performance significantly. JIT compiler is having multiple components. We are going to discuss each one in detail. So first is intermediate code generator. So it generates the intermediate code. Next is code optimizer. So whatever intermediate code has been generated, this code optimizer is used to optimize that intermediate code. Next is we need to convert this intermediate code to native machine code, and this can be achieved by target code generator. Now the main thing is profiler. In this case, we identify the hotspots. Hotspots means repeated method calls. Next is garbage collector. Garbage collector used to collect and removes unreferenced object from heap area and makes free space for new objects. It involves two phase, mark and sweep. During mark phase, GC identifies the unused objects in the memory, and in sweep phase, GC removes the unused objects identified during mark phase. Garbage collection is done by JVM at regular interval of time. We need not to worry about garbage collection, but we can trigger it by calling system.gc method, but the execution is not guaranteed. Next is Java native interface. So, like we know, other languages like C, C++ having some features that Java want to leverage. Like whenever we need to interact with hardware, or we want to have memory management, we need to manage our memory. So as we know, Java is not having concept of pointers, but we want to manage our memory. So in that case also we can use JNI. Next is like we know like other compiled language C, C++ is faster. So to overcome the performance constraint, we will use JNI. Next is native method libraries. Libraries that are written in other programming languages like C, C++. So these libraries are generally present in .dll or .so files. These libraries can be loaded through Java native interface. So thank you so much for listening. Please do like and subscribe the video.